Okay, welcome to the lesson on vector addition and subtraction part 1. Let's begin. Scalars versus vectors. A scalar quantity is a measurement that can be described with a single number giving its size or magnitude. Example, 20 degrees Celsius or 3 meters cubed or negative 3 degrees Celsius. Negative is not a direction. None of these numbers have a direction associated with them, and so they are considered scalar quantities. A measurement that includes both magnitude and direction is a vector. All forces are vectors, for example. A car moved all direction displacement are also vectors. So a car moved 2 kilometers in a direction 20 degrees north of east. That is a vector because it has both magnitude, 2 kilometers. That is the magnitude, the number, the value, or the amount. And then 20 degrees north of east is the direction. So it has both magnitude and direction, therefore it is a vector. And we can draw diagrams of vectors. Usually we draw an arrow pointed in the direction that the vector is headed. So this vector is drawn 30 degrees north of east. This is east, so if we start here, we're moving 30 degrees in the northward direction. So we're going 30 degrees north of east. Arrows are used to represent vectors. The direction of the arrow gives the direction of the vector. The length of the vector arrow is proportional to the magnitude of the vector. In other words, the greater the magnitude, the longer the vector would be. An arrow representing a force of 20 newtons would be, for example, twice as long as an arrow representing a force of 10 newtons. Vector addition and subtraction. In Physics 11, we looked at situations where the vectors pointed along the same direction. In such examples, the vectors can just be added together. Example 1, a car moves 275 meters due east, vector A. Then the car moves in the same direction 125 meters due east, vector B. The two vectors add together to give the resultant vector R. Adding these two vectors is similar to adding two scalar numbers. So here's a diagram representing the addition of the two vectors. So we have vector A drawn here, and vector B is drawn next to it. It's in the same direction. So it's drawn in the same direction besides the first one. And we say that we use the tail to head method. This is the method you will be using for all vector addition problems. You add the tail of the second vector to the head of the first vector. So this is the tail of vector B. The tail is the starting point, and this is the head of vector A, the end point. So the end of vector A is attached to the beginning of vector B. We say R equals A plus B, and we can just add the numbers like they were scalars. They're both east, so they just add together. And the resultant vector is drawn, which is drawn from the beginning of vector A to the end of vector B, the start to finish. And that vector is 400 meters due east. The subtraction of one vector from another is carried out in a way that depends on the fact that when a vector is multiplied by -1, the magnitude of the vector remains the same, but the direction of the vector is reversed. So for example, this person moving up the stairs is represented by vector positive d. Going up is positive. And then if you go down the stairs, it's represented by vector negative d. So the vector becomes negative, it flips the direction of the vector. The displacement vector for a woman climbing 1.2 meters up a ladder is d. The displacement vector for a woman climbing 1.2 meters down a ladder is negative d. The result or resultant of adding up all the vectors is as simple as elementary math. During the Physics 11 course, the rules for summing vectors, such as force vectors, were kept relatively simple. So for example, adding and subtracting vectors in Physics 11 was simply adding and subtracting positive and negative numbers together. So positive 5 plus a vector of positive 5 means they're in the same direction, and the resultant vector is positive 10. A positive 5 vector added to a negative 5 vector means that they are in opposite directions but exactly equal, so they cancel each other out and add to 0. And then you can see some of the other additions here. They simply add like numbers, like scalar numbers adding and subtracting together. In this Physics 12 course, the task of summing vectors will be extended to more complicated cases in which the vectors are directed in directions other than the vertical and horizontal directions. For cases such as those shown in the diagrams below, what is the resultant and how can it be determined? So we will start looking at cases where we are going to add vectors that are not all along the same axis of travel. And so they may be at angles to one another. Like this vector is pointed northeast, and this one is pointed northwest. How would you add them together? So we are going to start looking at cases like this. Using the Pythagorean theorem. When two vectors are perpendicular to one another, the Pythagoras theorem may be used. Example, a car travels 275 meters due east, that's vector A, and then travels 125 meters due north, that's vector B. The two vectors add to give the resultant vector R. R equals A plus B. They're perpendicular to one another, so we can't add the numbers together as they are. We have to use the Pythagoras theorem and draw a right-angled triangle. So here's vector A. We draw the first vector, and vector A is 275 meters due east. So it goes in the eastward direction. We draw the first vector, A. Then from the tail of the second vector is drawn at the head of the first vector. It always has to go tail to head. And so we draw the second vector B, which is 125 meters due north. And the resultant vector is always drawn from the start to the finish. So the starting point is the starting point of the first vector drawn to the end of the second vector. And we draw the resultant, and the arrow has to point in the right direction. Note they are still added head to tail to each other, and the resultant vector points from the tail of the first to the head of the last vector added. The method is not applicable for adding more than two vectors or for adding vectors which are not at 90 degrees to each other. We cannot add 275 meters plus 125 meters because the vectors have different directions. Since the vectors form a right triangle, we can use the Pythagorean theorem to find the resultant vector. So we take the square root of vector a squared plus vector b squared. So that's the square root of 275 squared plus 125 squared. This square root sign extends to the entire bracket, and that's equal to 302 meters. That means the resultant vector is 302 meters, but we still need to find the direction. The angle theta, if we go back to the diagram, is this angle here. So we're looking for this angle now. So the angle theta can be found using the tan function. Arctan negative of vector b over a, which equals arctan 125 over 275, equals 24.4 degrees. And then we have to give a specific direction relative to east or north. So we say the displacement of the car is 302 meters, 24.4 degrees north of east. The vector direction could also be stated as 65.6 degrees east of north. So there's more than one way to say the direction. It depends on what you are finding the direction relative to. Are you finding it relative to east or relative to north? So try this. What is the direction of the car's displacement relative to east, west, and north? Pause the video and give it a try. Okay, so relative to east, it's 30 degrees north of east. So this is the eastward direction. East is always rightward on the page. And 30 degrees is here. So that's 30 degrees north of east. So first we start at east and then we move 30 degrees in the northward direction. So that means the car is 30 degrees north of east. Okay, and then west, the car would be 150 degrees east of west. So if we're starting here, this is west, and the car finishes here. So we're going from this point all the way across to here. And that angle is 150 degrees because all the way is 180. So 180 minus 30 is 150. And relative to north, it's 60 degrees east of north. So if we start at north, we are traveling along this path to the vector, and that angle is 60 degrees because all the way to the line is 90, and we know this is 30, so 90 minus 30 is 60. So it's 60 degrees east of north. So there's three ways to write the direction. Generally speaking, we would probably not use this one. We would either say this or relative to north. Either of them would be correct on a test question. Okay, try the following problems on a separate piece of paper. Pause the video and then check your answers when you're done. Okay, here are the answers to the questions. Check your work. Ask Mr. Johal for help if you had anything incorrect. Remember, there's more than one way to say the direction, so you can check if you wrote it differently, then you can just check and make sure that it's still correct. All right, now what you can do next is try the practice question worksheet. And once you're done that worksheet, show it to Mr. Johal, and if everything is correct, then you can try the practice questions from the textbook on page 21, which is question 21, 22, 23, 24, and 25. Okay, that concludes the presentation.